Hello girls, this is Mrs. Kleimanns and I am going to talk to you about volcanoes today. Here are the learning objectives that we're going to talk about today. Recognize the Pacific Ring of Fire on a map and explain what the Ring of Fire is and where it is located. Then state the two main physical features found at plate boundaries. Explain how the different forms of boundaries occur, and discuss the physical features formed by the different types of boundaries. And lastly, about volcanoes, label the main features of a volcano, describe in detail the features of a volcano and compare the two main types of volcanoes. And lastly, compare and contrast the two main types of volcanoes and link structure and lava type to the type of eruption. This is a volcano, and a volcano is a place on the Earth's surface where molten rock and gases erupt through the Earth's crust, so they come out of the Earth's crust. Some volcanoes are just cracks and weak points in the Earth's crust where lava erupts, and some others are domes, shields, or big mountain-like structures with a crater at the summit. Basically, there are two places where you get volcanoes. The first one is where tectonic plates collide. And that's where one plate may slide below the other, called the subduction zone. You have learned in previous lessons that the Earth's crust is made from several plates and that the plates move around, driven by the convection current in the mantle. And where they come together, you can have several types of boundaries. They can either collide head-on and then you get mountains, or they can slide past each other, or they can move away from each other, or one can sink under the other. And that's what's called a subduction zone. When that happens, the sinking plate melts from the heat and the friction. And the melting rock then turns into magma, and when there is a lot of magma, it might force its way to the surface through the cracks in the crust, and that is then caused a volcano. And when a volcano explodes, we call that an eruption. Secondly, volcanoes can also develop over so-called hotspots in the mantle. A hotspot is a localized accumulation of hot and liquid magma. So magma is like molten rock. And these hotspots can occur anywhere. They are not linked to plate boundaries. And occasionally this molten rock or magma can break through the crust, and then you also get a volcano. Here we see a diagram of a volcano and all the different parts that make up a volcano. So magma down here is molten rock within the Earth's crust. And when this magma erupts through the Earth's crust surface, it's called lava. So while it is still in the crust, we call it magma. When it comes out and then cools down here, we call it lava. Lava can be thick and slow moving or thin and fast moving. When a volcano erupts, it can also throw out solid pieces of rocks, and these are called volcanic bombs. The other thing that can come out is ash. Now it's important to mention here that that kind of ash is not the normal ash that you get when you burn a little bit of wood in your wood burner, but it is basically rock that is ground up into powder. So this type of ash is really heavy and can, when it falls onto structures and accumulates, it can actually make these structures collapse, like a roof of a house, and it definitely has a very bad effect on a human's respiratory system. And then there can be something which is called pyroclastic flow. This is here, pyroclastic flow. So a pyroclastic flow is a fast-moving current of hot gas and volcanic matter. And it can, when I say fast-moving, the speed it can have is between 100 and 700 kilometers an hour. So that is really fast. And normally when you drive through the city, you drive maybe 40 or 50. When you drive on a highway, you might drive 100, and this can go up to 700. So that's the speed of an airplane. It's really fast. So there's no way to outrun this or even get away from it with a car, and that's why it's really important that people get an early warning and can evacuate before a volcanic eruption happens. This here is called the volcanic vent. This is where the magma comes out, and there is a main vent. There might also be side vents, when they're called secondary, and they might also form secondary cones. The other thing that you see here is that this volcano is made up of layers, and that's because each time the volcano erupts, another layer of lava is laid down on top of this volcano. So this lava flow here will eventually cool down and will turn into solid rock and will form another layer on top. So basically each layer represents a volcanic eruption. You can see that this volcano erupted several times, and each time it grows a little bit and becomes a little bit bigger. New Zealand has a lot of active volcanoes and a high frequency of eruptions. It's very special about New Zealand. Most New Zealand volcanic activity in the last 2 million years has occurred in the extremely active Taupo volcanic zone. So that's where Lake Taupo is, and Mount Ruapeo and Mount Tongariro, and all these big volcanoes in the center of the North Island. We have 3 major types of volcanoes in New Zealand: volcanic field, cone volcano, and calderas. The volcanic field is the first one, and that's what we have in Auckland. So the volcanic field, these are the type of volcanoes that develop over a hot spot. So Auckland is sitting on a hot spot. We have a magma chamber in the crust below Auckland. So the volcanoes in Auckland are not formed by tectonic movement. They are formed because we sit on a hot spot. The other type volcanoes, cone volcano and caldera volcano, these are the volcanoes that occur in the Taupo volcanic area, and they are formed by a subduction zone. So the cone volcanoes include 3 frequently active cone volcanoes: Ruapeo, Tongariro, and White Island. As you all know, White Island just erupted recently. And then we have caldera volcanoes, including Lake Taupo. And caldera volcanoes are volcanoes that erupt really violently. They basically blow off the tip of the volcano. And then when the eruption is finished, the side walls of the volcano collapse, and then the magma chamber fills with water, and that's how you get a lake. So basically Lake Taupo is a lake in the crater of the volcano. New Zealand has so many active and extinct volcanoes because we sit on top of a subducting plate. So here you can see the northern part of the North Island. Here is Mount Ruapeo, somewhere here is Auckland, and this part of the country sits on the Australian plate. And here, out here, is the so-called Pacific plate, and here, this is where the boundary runs between those 2 plates. So the Pacific plate bumps into the Australian plate where New Zealand is, and then it moves under. And when this happens, all this rock that was previously making up the crust melts because it's here under here, down here it's under a lot of pressure, and it's also very hot, so this rock melts, and then it can move up through the crust, through cracks in the mantle and in the crust, and when it reaches the surface and there is enough pressure, it will come out in a volcanic eruption and form a volcano. So the hot magma between the two plates is squeezed up through the crust. New Zealand lies on the Pacific Ring of Fire, and it's called Ring of Fire because there are so many volcanoes, where movement of the Pacific plate causes many volcanoes. Some New Zealand volcanoes lie under the ocean on the Kermadec Ridge. So when we look at the map, here is Australia, down here is New Zealand, here is North America, South America, and you see this red line here, this is the Pacific Ring of Fire. So you see here is the Pacific Ocean, and this Pacific Ocean sits on the Pacific plate, and all around here is where the Pacific plate borders any of the other plates, and in these subduction zones, that's where the volcanoes form. So all around here are many, many active volcanoes, and they, especially in the last few years, they have been quite active, and there have been several eruptions, and obviously the latest one, White Island, as you all know.